Hi everyone, in today's video we are going to continue working with the properties of exponents, but today the exponents are going to be rational numbers or fractions. So we're going to perform operations with these rational expressions. We are going to simplify the expressions using the exponent rules. We're going to be converting between rational exponents and radical expressions, and then we're also going to be simplifying expressions completely by using the exponent rules and also radicals. So first, I just wanted to kind of roll us back to elementary school and let's review operations with just fractions because we're going to be using these within the things that we're doing today. So first, let's talk about multiplication. When you have two fractions, you are going to multiply directly across the top. So 1 times 3 is 3, and directly across the bottom. 5 times 4 is 20. If it simplifies any, you'd simplify. That one does not, so we're done there. The thing with division is we're going to take division and change it to be a multiplication problem. So the way that we do that is by keep, change, flip. We're going to keep the first fraction exactly the same. We're going to change the division sign to be multiplication, and we're going to flip the second fraction. So instead of 2 over 9, this one becomes 9 over 2. Now from here, I am going to look and see if there's any dividing out that I can do. 5 over 6 and 9 over 2 don't simplify, but 9 and 6 are both divisible by 3. And because this is multiplication, we can do that simplification. So 9 divided by 3 is 3, and 6 divided by 3 is 2. Now we have a simple multiplication problem. So we're doing 5 times 3 in our numerator and 2 times 2 in our denominator. That's 15 over 4. It doesn't simplify any further, and so we're done. All right, with adding and subtracting, the denominator matters here. So in this first one, you'll notice that the denominator is 7 in both fractions. We have a common denominator, so we are able to add across the top. We're doing 3 plus 2 in the numerator all over our common denominator. So that is 5 over 7 for our final answer. Now, the second and third problems here have unlike denominators, and we need to get common denominators or like denominators before we go any further. So this first one, 7 and 3 don't have any factors within them that are common. So I'm going to multiply 7 times 3 together to get the LCD, the least common denominator, of 21. So what I'm trying to do here is I want both of these denominators to be 21 because that's the smallest thing they have in common. So in order to do that, I am going to multiply this left side by whatever it takes to get 21 down in the bottom. 7 times 3 is 21, so that's why I'm going to choose that. That's going to give me a 21 down in the bottom, and I'm going to have to do it on the top too. So 3 times 3 is 9. Over on this right-hand side with this fraction, I'm going to multiply it by something on top and bottom, and again, I'm trying to get it to be 21, so I'm going to multiply by 7 over 7 because 3 times 7 is 21. Up top, that gives me a 14. So I now have matching denominators like I did in the previous one, so I can go ahead and add them together. It gives me 23 over 21 for my final answer there. All right, now looking at this next one, I'm not going to do 3 times 9 to get my denominator because when I see 9, I see that 9 has a 3 in it already. 3 times 3 is 9. So my least common denominator is going to be 9. That means when I rewrite this to multiply by whatever I need to multiply by to get a denominator of 9, I'm not going to do anything over here to this right-hand side because it already has a denominator. This left-hand side, I'm going to multiply by something that I can get to 9 with. So 3 times 3 on top and bottom, that gives me a denominator of 9. 3 times 3. Up top I have 3 times 2, which is 6. And because I have common denominators now, I can subtract and get 1 over 9. Okay, so I hope that was a nice little review for you. We are going to use those operations today, especially the multiplication and the adding and subtracting. All right, so let's get into it. These are the same properties that we worked with in the previous lesson. We're just using fractions as our exponents now instead of integers. So you'll notice the product property is still the same. If you have two bases that are the same, you can add together the exponents. So in this one we have a base of 5 raised to the 1/4 plus 2/4. Now if we look just at this exponent for a moment, you'll see that we have common denominators here. Because we have common denominators, we can just add across the top. So I'm going to leave my base the same, my denominator is going to stay the same, and 1 plus 2 is 3. So I've successfully added together my fractions there. Now in the second one, I have x to the first power plus 1/2. And I do need to get common denominators here because 1 is the same thing as 1 over 1. My common denominator, my least common denominator, is going to be a 2. So I'm going to have 2 over 2 plus 1 over 2. And that gives me x to the 3 over 2. And we're going to stop there for now. The power property is the same as it was before. When you have a base with a power raised to another power, we're going to multiply. So we're going to multiply these two fractions together now. So we have a base of 3. We're doing 1/2 times 2/3. Notice that there's a 2 in the numerator and the denominator. Because this is multiplication for the operation here, those are going to divide out to be just 1. So I have 3 to the 1 times 1 over 1 times 3, which means I have 3 to the 1/3 for my power property application. Let's look at the second one. This one, 1/3 and 4/7 doesn't have anything that I can divide out, so I'm just going to multiply straight across. 1 times 4 is 4, 3 times 7 is 21. That does not simplify, so I'm all done there. The zero power property is still the same as it was because 0 is your exponent, so 2 to the 0 is still 1. S to the 0 is also still 1. That property has not changed at all. With the power of a product property, because this is a product in parentheses, we can take that power of 1/2 and say 3 gets raised to the 1/2 and 2 also gets raised to the 1/2. This is still multiplication in this problem. Those bases are not the same, so we cannot use the product property, and for now that one is done. Let's see, last one here, c to the 1/4 times d to the 1/4 finishes that one up because that is just a multiplication problem. The negative exponent property is going to be the same as it was before. So I have a base of 2, that's over a 1, and I have a fractional exponent this time. So remember that negative fractional exponent is going to take that base with that power and move it to the other side of the big fraction bar. So I'm going to have 1 over 2 to the 1/5. In this bottom one, I have 2 to the -3rd in the denominator, so that negative exponent is going to make it come up to the top and be 1 times 2 to the 3rd. And I'm going to go ahead and simplify that to 8. It's all over 1, and that's my simplest answer there. With variables, we're going to have the same premise. So this k base is over 1. So when it moves to the other side of the fraction bar, it's 1 times k to the positive 2/3, and there's a 1 up on top. And this r to the negative 6th power, when it moves up to the top, that 2 is staying there because the 2 has a positive exponent. So it's 2 times r to the 6th power. That's all over 1 because the entire denominator moved up. So it's just 2r to the 6th. All right, so let's talk about the last couple of properties with quotients. Again, these properties are the same. We're just dealing with fractions and our exponents now. So if you have a quotient, meaning a quantity that has a division sign or fraction bar in it, you are able to raise the top, the 1, to the 1/2 power, and also the denominator, the 3, to the 1/2 power. We're going to stop there with that. We are going to do more with some of these later on in this video. The same thing is also true when you have variables. That's g to the 1/3 over h to the 1/3 because it is just a quotient division. All right, the power of a quotient rule. Remember, that's when you have the same base, you can subtract the two exponents. So in this first one, my base is 5. My top fraction, or my top exponent, is 4/7, and my bottom one, I'm subtracting it, is 2/7. I got lucky here. I have common denominators, so I'm going to leave that denominator and just do 4 minus 2 is 2. And that's where we'll stop for the moment. The ones with variables work the same way. I have a base of v. I do my top exponent minus my bottom exponent. I again got lucky and have common denominators, so 5 minus 1, that's 4 over 8. Now that is going to simplify because 4 over 8 is the same as 1 over 2. So I am going to simplify that the last little bit of the way. All right, so that was a review of the exponent properties, but we have fractions, rational expressions this time. So now let's talk about where that's going to help us. There is this really great, super helpful way that we can use exponents, and in particular fractional exponents. When you have a base with a fractional exponent, we can rewrite that as a radical. So you'll notice here we're going to be doing base, where the exponent is the power of the radical or of that base, divided by the type of root we're taking. So in this first example, the base is 36, so I'm going to draw a radical and put the 36 inside of the radical as the radicand. And then the top number, this 3, that is the power. So the 36 is going to be raised to the 3rd power. That's all inside of the radical. The bottom number is my index. It tells me what type of root I'm taking. So in this case, this is a square root. So 36 raised to the 3 over 2 is the same thing as the square root of 36 to the 3rd power. Now, I also want to point out that you can also, and it's rarely but sometimes helpful, write the power, that 3, on the outside. So this is a square root, and then it can be raised to the 3rd power. I wouldn't do this unless you're only working with one base, and we'll look at why that is when we get a little bit further in. For this problem, simplifying it, it makes it easier to simplify because I know the square root of 36. It's 6, and then I can raise it to the 3rd power and get 216. The alternative would be to take out a 36 and then take the square root and multiply those together. It still gets you there, but for this one, writing it in this format makes it a little bit quicker. The main takeaway, though, I want you to have right now is that power over root. That's how we're going to rewrite that fractional exponent as a radical, so then we can simplify the radicals. So let's just practice converting between notation formats first. This first problem is the square root of 3. So the power in here with the 3 is a 1. And because this is a square root, that is a root 2. So my base is going to be 3. The power is the 1, and that's over the root of 2. So it's 3 raised to the 1/2. So the second one, the base is 2. The power with that 2 is a 1. The type of root is a 3. So that's a 2 to the 1/3 power over root. This third one that you have, the base is an x, and then we have a power of 2. Bottom of the fraction is the type of root, so that's a 5th root. x raised to the 2 over 5. So we've successfully converted all of those radicals to the exponential rational exponent notation. So now let's go the other way. And the other way is going to be the thing that we do most often here. So you're going to be given a base with a fractional exponent, and we're going to write these as radicals because then we can simplify them and we get rid of fractions too, which is always a happy day. So let's write this first one. We're going to draw our radical. The base is a 2. Remember, this is power over root. So the power is a 1 and the root is a 4. So this is a 4th root of 2. The second one, I'm going to draw my radical. My radicand base is an x. The power is a 3, and this is a 5th root, power over root. So that one doesn't simplify at all. I'm going to leave it right there. Just as a sidebar from earlier, you could technically also write this one as a 5th root of x, that whole quantity raised to the 3rd power. It doesn't help us simplify this one though, so I wouldn't necessarily worry about doing that. All right, this last one, number 6, we're going to draw our radical, put our 27 inside. The power is a 2, and the type of root we're taking is a 3. That's power over the root. Now in this one, I see something that I can simplify. I like the cube root of 27. I know the cube root of 27 is 3. So I'm going to rewrite this one as the cube root of 27 quantity squared. Because the cube root of 27, as we just said, we can simplify it. And then 3 squared is something that we can simplify as well. So that one did simplify, and it helped us to write it with the power on the outside. Again, the base was just a 27. There was only one base, so that kept it pretty simple. Let's do some work with these now. So let's look at some problems where we are going to use some exponent rules to do some combining, and then if there's still a fractional exponent after I use the exponent rules, I'm going to need to turn that into a radical to finish simplifying. So this first one says we have the same base, they're being multiplied together, 5 to an exponent times 5 to an exponent. So my exponent properties say I can leave my base the same, and because this is multiplication of those bases, I'm adding together my two exponents. I have common denominators here, so I'm going to combine these and put a 2 there, and 3 plus 1 is 4. And then I can simplify that further because 4 divided by 2 is 2. And then 5 squared is 25. So that one simplifies to 25. All right, let's look at this next one. We have a base with a power, and then it's raised to this other power of 1/2. So that means we're going to use the rule where we have a power raised to a power, which is multiplication of those two exponents. So with multiplication, remember that hopefully is the easy one. You multiply straight across the top. 2 times 1 is 2. Straight across the bottom, that's 6. That fraction does simplify, so I'm going to go ahead and simplify it to 1/3 because both 2 and 6 are divisible by 2. And this one, when we were doing our exponent rules just by themselves, we'd say that's done. But because we know how to convert between notation formats, we are not done with that fraction as an exponent. We're going to use power over root to write our radical with an x. Remember, the power is the top number, that's my power, and the type of root is my bottom number. So that means this is the cube root of x. Let's look at another one. This one, I have a fraction bar, and there is a base of 3 on both sides. Now this top 3 has a exponent of 1. So the quotient property says I can leave my base the same, and I can do my top minus my bottom, but my bottom is -4/5, -4/5. Now, if you wanted to move that negative exponent up to the top first, you could do it that way too. It would get you to the same answer. Look what happens this way, and then we'll look at it that way. I'm going to be adding those two because a negative, when you subtract a negative, it becomes a positive. And then I need to get common denominators, so that's 5 over 5 plus 4 over 5, which means I've got 3 to the 9/5. If I had done it the other way, if we come down here for a second, and I had done 3 to the first over 3 to the negative 4/5 and brought that bottom fraction up to the top, it would have made it a positive 4/5. And then I would have done the product property, which says 1 plus 4/5. And that's the same place I was in just a moment ago. This 1 plus 4/5 is the same thing I got to up here. So it would have been a couple more steps, but it still would have worked. So you can do these whichever way you see the rule that you want to use, go for it and see what happens. Now I'm not quite done with this one yet because I still have a fraction as my exponent. So I'm going to continue to work on this one by turning it into a radical. The base is a 3, and I've got a power of 9 and a root of 5. So from here, if I have 9 3's inside, that means I do get to take out a set of 3's because there's 5 of them. And then I still have inside of that 5th root the other 4 left over. And then I'm not going to be able to take anything out, so I'm just going to rewrite that 3 to the 4th as an 81. So my final answer is 3 times the 5th root of 81. All right, so let's look at just a few more of these to get you a little bit more comfortable. I know lots of examples on these are always helpful. So this first one, I have bases the same, they're being multiplied, so that means I'm going to add together my exponents. That's 1/8 plus 5/6. This one I do need to get common denominators for. So I'm going to go down here in the margin, I think, and work this out so that we have a little bit more space. So I'm doing 1/8 plus 5/6 in this one. So I need to find my LCD. I'm thinking for my LCD that I want to use 24 because 6 times 4 gives me 24, and over on this side 8 times 3 gives me 24. I don't want to use 48 because then I'm going to have extra simplifying to do at the end because that's a bigger common denominator. It's not the least common denominator. So I'm going to multiply on top and bottom by those things. That gives me 3 over 24 plus 20 over 24. So I'm looking at 23 over 24 as my fraction up here. So I have y to the 23 over 24 power. Now because I have a fractional exponent, I am going to rewrite this as a radical, y to the 23rd, and that's a 24th root radical. If I only have 23 y's, it's missing one. I don't have 24, so that's my final answer for that one. Let's look at the next one. This one looks like it has a lot going on. A couple of things to notice. The bases are not the same in this one, so I can't add together those exponents. They are, however, in a quantity that's raised to a power of 3. So I'm going to take each base with its and exponent and raise that power to a power, which means I'm going to multiply. So let's write that down. And I'm putting these 3's over 1's just so it's a little bit easier to think about. I also see some division that happens if I look just up at this fraction for a minute. Those 3's divide out. That leaves me with 5 to the first power. And then the x doesn't have anything that divides out, so that's x to the 3 over 4. Now I'm not quite done with this one because I have that fractional exponent. The 5 is done. 5 to the first power is just 5. So I'm only going to draw a radical with this base of x inside of it. The power is a 3 and the type of root is a 4. That's power over root. The x to the third can't come out of a 4th root, so that one is done now. Looking at this next one, I see a lot going on. I do see different bases, so I can't do much with the inside yet, but on the outside I see a negative exponent and I see a fractional exponent. So we're going to have to do some flipping, and we're going to have to do some distributing, and then we're going to have to do some radicaling. So let's flip it first. This whole thing is over 1, so let's move the whole thing to get rid of this negative down to the denominator. So that is 2 to the 6th times 4 to the 6th, all raised to the power of 1 over 6. Now, because this is all multiplication, I can go ahead and, what's going on with my pen? All right, I can go ahead and, there it is, distribute that 1/6. So, goodness. So if I distribute that 1/6, that's going to give me 2 to the 6th times 1/6, and that 6 is over 1, times 4 to the 6th times 1/6. Okay, so let's look at those fractions. These 6's divide out, and that's really good because that leaves me with 2 to the 1st power. These 6's divide out, which leaves me with 4 to the 1st power. So I have 1 over 2 times 4. All of my fractional exponents are no more, so my final answer is 1 over 8. All right, next one. This is a quotient problem. Look at that fraction bar. I have the same base on top and bottom, so I'm going to do 10 raised to the 1st power, that's the top, minus the bottom, 2 over 5. Now this one I need to get common denominators for, so that 1 is going to become a 5 over 5. And then I can do my subtraction with my like bases, or like denominators. So 5 minus 2 is 3. That gives me 10 raised to the 3 over 5. And when I turn it into a radical, because I have a fractional exponent, my base is 10, my power is 3, and the type of root I'm taking is 5. I can't simplify that 10 to the 3rd power. I don't have 5 of them, so they can't come out. I'm just going to leave it just like that. You could put in your calculator 10 to the 3rd and write that number. It's going to be some really big number. All right, the next one, oh look, it's the same problem, but it has x's in it. So this is still a quotient problem because of that fraction bar. I have x to the 1st power minus the bottom power of 2/5. That means I have x to the 5 over 5 minus 2/5, which is x to the 3/5. I have a fractional exponent, so I'm going to write it as a radical. My base is x, power over the type of root being taken. That one is also simplified there. All right, this last one, it looks like a bear, but it actually has something really beautiful about it. Do you see how this quantity is all raised to the 0 power? What's anything raised to the 0 power? Just 1. So this is the same as 3 times 1. Final answer for that one is 3, and I'm done. I told you in that last video, 0 power is probably going to be one of your favorites, I think. Just be careful not to include everything. The answer is not just 1, it's 3 times that quantity that's 1. All right, so in this video, we talked about how to perform operations on rational expressions. That was just reviewing the fractions. We simplified expressions using exponent rules. We also converted back and forth between rational exponents and radical expressions. And then we put all of that together to simplify expressions by using the exponent rules and also the radicals. Go ahead and try those couple of Now You Try problems for us to talk about in class.